Greetings and welcome to lesson R1. We're going to be discussing place values, a name for our numbers. With all things, numbers have names, and we also have names for the places where the numbers sit. For example, when we have a number, the very first position on the right is in the ones place value. The next number to the left of the ones position is the tens position. That's the place value. Next is hundreds, thousands, 10,000s, 100,000, millions, and 10 millions. And you can see, position from the right, the first position is the ones position. And I just went through the first the first 8. But after that, we still have names for those placeholders. 100 millions, billions, 10 billions, 100 billions, trillions, 10 trillion, 100 trillion, and so on and so forth. So we have names for all of these placeholders. In common use, we might not use sextillion or septillion, but we probably will use hundreds and thousands and millions even on most occasions. For example, when we are talking about numbers, each number has a name. So 524 would be 542. And 73401,658 would be 73,401,658. Now, if we want to expand the form of a number, using expanded form, using place values, we can see for 542, we have 5 100s, 4 10s, and 2 1s. And if we were adding them up, 500 plus 40 plus 2 would give us our 542. Another example would be 354,798. If we break it down in expanded form, that will give us 300,000, so 3 100,000s, 50,000, 5 10,000s, 4,000 is 4 1,000s, so we have 4 in the 1,000s position, 7 hundreds, 90, which would be 9 10s, and 8, which is 8 1s. If you add up them separately, it's 300,000 plus 50,000 plus 4,000 plus 700 plus 90 plus 8 will give us the number 354,798. The great part about that is we wouldn't want to use this expanded form all the time. So we do condense it down into this quote-unquote smaller number. Now you can see another example, 5,079. We can break that in expanded form into 5,000 plus 70 plus 9, following along the same techniques. So when you're writing words, I will say that the numbers, when you get to 21, they have a hyphen in it. Believe it or not, I know a lot of people skip that hyphen, but it's 1, 2, 3, 4, 5, and you can see the spelling of each number. That is an X, 16, 17, 18, 19, 20. Then we get to 21. There is a hyphen in it. 22, 23, 24, 25, all the way up to 30. Then again at 31, 41, 51, 61, all the way through 100. Okay, so 99 has a hyphen in it. Let's change gears just a little bit and talk about sets of numbers. Now, sets are just a group of similar objects. We have our counting numbers. Now, even if you didn't know what your counting numbers are, if you went and I told you, hey, count these numbers of balls in this bucket, you would start with 1, 2, 3, 4, 5. This is what we've been doing from early on in our life. We've been counting things, starting with the number 1 and going on until indefinite. So I can count 100 different items. 1, 2, 3, 4, 5. Now we have another set of numbers, which are the whole numbers. The whole numbers are just the counting numbers, 1, 2, 3, 4, 5, 6, 7, and we include 0. So the counting numbers, we start at 1. Whole numbers, we start at 0 and move forward. The counting numbers, if we were to put them on a number line, we start at 1. We draw our line to the right with an arrow, and every unit equidistant or equal distance. So if I stuck my finger on there and my next dash was right next to my finger and I did another one and another one and another one and another one, I like to see them equal distance because that's what they are. It would say 1, 2, 3, 4, 5, 6, 7, but I can't do it for all of the counting numbers. So this nice little arrow to the right signifies that this goes on forever. Whole numbers on the number line look very similar, except this time I'm starting at 0 and counting 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And again, with an arrow signifying that this line never ends. That's it for this lesson, so until next time, be seeing you.